starting with the first one, your variables can be different from mine, that's okay. As long as they're set up the same way, that's really all that matters. So you should have your two variables added together to equal 20, because the total number of apples and the total number of oranges would equal the total pieces of fruit. And then all of your prices should go together. So 1.25 times whatever you use for apples, and then 0.95 times whatever you use for orange. I would probably avoid using O, just in case you mistake it for a 0. And then equals the total spent. It also said define your variables, so remember, don't just put A equals apples. It should be specific number of apples or total number of apples, either or. Do you have any questions on number 1? Number 2, I use S and A. If you use X and Y or something different, that's fine. Your two equations should have been the two variables added together to equal 238. And then the other one should have your prices, so 6.75A or whatever you use, plus 3.50S or whatever you use, equals 1,252.25. However you solve that, your S should have been 109, because that's what you were looking for. Anyone need to see that worked out a specific method? For number 4, you should have set up your two variables. That could have been X and Y, S and B, whatever. And then your two equations. Together they have 70 sports cards, so you're going to add the two variables. They should equal 70. To set up your other one, again, think backwards. If I know the amount Susie has, and I multiply it by 2, and then I add 10 to it, I would get the amount Susie's brother has. So it should be B, or the brother equals the equation. Then if you put this back in, if you take this and you substitute it in for B, this is the work for that. So you would then combine your like terms and solve for Susie's variable to get 20. And if you put that back in, it works because B would then be 50. 50 plus 20 equals 70. 2 times 20 is 40, and 40 plus 10 is 50. So those both would work. Now, if you solve this one by graphing or elimination, that's fine too. Substitution would just be the easier of the 3, because it's already set up for that. Right.
In the red section, the second equation,
Combining these two, the 2Z and the Z. Okay. Any other questions on this one or the other one? If I pass out a review to you last class, raise your hand. Everyone should have the review in front of them. We're going to go through some of these. If you see any that we don't go through, circle them, and we'll go through them if we have time at the end. Make sure it's good. To start off, we're just going to do one of the graphing problems just to remind ourselves how to do that. And we're going to do number 4. Okay. So with this problem, with your graphing problems in general, yes, you can use Desmos, but for these, I do want you to put them back in slope-intercept form. You can definitely check yourself with Desmos, but you should be showing me the work to put this back in slope-intercept form. So if I'm doing that, I would need to subtract my 8x on both of these equations. So this first one, so far I have 3y equals negative 8x plus 12. And my second one, I have 3y equals negative 8x minus 9. I just did them at the same time. And then we would need to divide them both by 3. We have y equals negative 8 over 3x plus 4. And y equals negative 8 over 3x minus 3. What do we know about these two without graphing them? They have the same slope, which means they are parallel, which means what about the solution?
They're not going to have a solution.
They're not going to have a solution.
We still need to graph them both.
With these, I would do them in like 2 different colors, that way you can see them both. It's not necessary to do that, but I'm going to do that since it's started here. So one's going to have y-intercept of 4, and a slope of negative 8/3. We're going to go down 8, and to the right 3, and draw a line through that. Make sure your line has arrows. The second one is going to be at negative 3 with the same slope, so we go up 8 and to the left 3. And draw my line. So on top of drawing your lines, you also need to state your solution, whatever that may be. In this case, it was no solution, so you still need to state that. Do we have any questions on the graphing section? Or on this problem so far? Moving on to substitution, move to the next page. We're going to do 3 of these together. Number 7, number 8, and number 11. With substitution, remember that you need to have an x or a y solved by itself. Do we have that? No. So that means we need to get one of these to be x or y by itself. Look for the one that is or has a coefficient of 1, and we'll solve for that one. You can solve for other ones, but be mindful that you'll have fractions, and then be careful with the fractions. So we would subtract 3x on both sides to get y equals negative 3x minus 3. Then take that and substitute it into your other equation, where y is. Pay attention to what you have. So I have a y equals, so it needs to be substituted into a y. If you solve for x, it needs to be substituted into an x. After you substitute this in, go ahead and solve for x, distribute, combine like terms. In this case, when I combine my like terms, what happens here? It becomes 0. That means I no longer have x's. What type of solution would this be? No solution. No solution. So when you have that, when they disappear, when they cancel, don't put 0x and then still continue on with x. Just leave it alone. Don't put it at all. Questions on number 7? Let's do number 8. For number 8, same thing. These are not, one of these is not already solved for x or y, so we have to find one that is. Here we have an x that has a coefficient of 1, so we're going to solve that equation for x by subtracting for y on both sides. Once we have that, we can take that, substitute it into the other equation where x is. So this is going to be 2 times negative 4y minus 3 minus 5y equals 7. Distribute, combine your like terms, and start to solve for y. When we combine our like terms here, we get negative 13. We can add 6 to both sides. And divide both sides by negative 13. After you find one of them, you need to go back and find the other. So we found y, we need to go back and find x. So we can put this value in for x. X equals negative 4 plus negative 1 minus 3. That would give us positive 4 minus 3, or 1. And then the very last thing, make sure that your answer is in an ordered pair if you have an x and a y. So 1, negative 1. you have any questions on number 8? Alright. Moving down to number 11. Both of these equations have a y equals. How would I use substitution here? Yeah. I'm going to make them equal each other. It doesn't matter which side I put what on, but I need to set it up like an equation with variables on both sides. So it's going to be negative 4x plus 8 equals negative 3x plus 8. Anytime you see that, whether it's x, whether it's y, set them equal to each other. And then solve. What do we want to move first?
Eight.
Okay. So if we subtract 8 on both sides, they disappear. Now what? If we wouldn't divide, we need to get all the x's on the same side.
Subtract or add.
Add, in this case, which one? Doesn't really matter. Okay. So if we add 3x, we get negative x equals 0. And then, am I done?
No.
What do I still need to do? Still equals 0. But I do need to do this stuff. Okay. Then I would put 0 in for y. I'm sorry, 0 in for x into the y equation is what I meant to say. It doesn't matter which one, you're going to come up with the same answer either way. Which is 8. Really, we kind of knew that because our y-intercept is 8. And if you think about this, like if you were just looking at the equations and notice that they both have the same y-intercept, they would have to cross at that y-intercept. Do we have any questions on 11? We're just going to do a couple of the elimination problems. Which ones did I say? 15 and 21. Remember, with elimination, you need to have the same coefficient. So if you don't have that, you need to make them similar. You can't just add or subtract them, even if they're not the same. So, do we want to eliminate x or y first?
X.
Okay. So if we're eliminating x, we need these two numbers to be the same. What is the number that they both go into? 12. So we would need to multiply our top by 4 and the bottom by 3. Now if we got rid of y first, then we would really only need to multiply one of them by one number. But it doesn't matter. So you have 12x plus 4y equals, what is that, 84, negative 84. And negative 12x minus 18y equals 0. To get rid of x, would we add or subtract?
Add.
We would add them because they're different. So if you have a positive and a negative, add them. But if they're the same, whether that's positive or negative, subtract. Show me how you eliminated them, whether that's adding or subtracting. Show me that. Right here, if we add these two together, these become 0. 4 plus a negative 18 is the same thing as 4 minus 18, so negative 14y. Negative 84 plus 0 is still just negative 84. Divide that, tell me what y is. Positive 6. Then we can put that into any of the 4 equations we have and find our x. X plus 6 equals negative 1. Subtract 6 on both sides. And divide both sides by 3. So our solution here would be negative 9, 6. Do we have any questions on 15? Moving on to 21. Do we have similar coefficients? I heard yes and I heard no. What is the similar, or which one has similar coefficients? Why? It has a negative and a positive. That's okay that they're different because now we can do what to eliminate them? We would add if they're positive and negative, subtract if they're the same. Now, if you wanted to, you could multiply one of them by a negative to make them both the same so that you could subtract. That's definitely an option. Do you have to do that? No. So if we are adding these two together, x plus a negative would be the same thing as x minus 5, so negative 4x. These would cancel. And then 11 plus negative 23 is the same thing as 11 minus 23, which is negative 12. Thank you. And then we could divide. Then we can put our x value into any of our equations to find our y value. Let's do this first one. 3 minus 2y equals 11. Subtract 3 on both sides. And divide both sides by negative 2. So our ordered pair would be 3, negative 4. Do we have any questions on 21? We'll do one of the word problems, and then if you have specific problems you want to go over, we will go through those. So we're going to do 26. take a second, read this, and then tell me what's important. What did we find most important here? Say,
Every time they take a ride, they're take a stamp.
Yeah. Now, in the wording, that's not really important, but seeing it here, that's important. So really, I'm gonna like highlight this entire thing. All of that information is important. What are we looking for? Ma'am. So basically, we're looking for both. Okay. Let's define our variable, set up our equations, and then we'll decide if we want to see this done all three ways, we can do that. Or if we just want to see specific, we'll do that. First, we don't know how much it costs for each, so those are going to be our variables. You can call them F and W, W and S, doesn't matter. And this is going to be the cost of a ride, one ride on the Merrill. Now, when you look at this, because they put the number, each one is stamped, those numbers and our variables are going to go together. Our totals are going to be what they equal. So technically we have 6 numbers here, so all of them are going to be equal. So we could say for this, I don't know whose is whose, but 1 is 3 for the water slide, so that would be 3W. And then 3F is going to equal 1770. And then the other one will be 2W plus 3F equals 1550. Okay. Now this one is set up really nicely for which method? Elimination. So we will do it that way, but if you want to see it done another way, we will do that as well. So our F's will cancel by doing what? Adding. Subtract. So when we subtract 3 minus 2 would just give us 1W. Our F's would cancel. Someone subtract this. I think it's 2. Then we need to put this back in and find the cost of one ride to the Ferris wheel. Doesn't matter where you put this back in at. What would that be? 6:45, I think. And then we could subtract. 3x equals 1135? 25. I was close. And then divide it. Tell me what that is.
75.
75. Make sure you have your units. So here we're looking for cost. So your units would be dollars. And when you're doing your word problems, when you get to your answers, like box them in so I know those are your answers to look in. Or you can rewrite them somewhere off to the side and put them together. That way I know those are your answers. Does anyone want to see this using substitution or graphing? Graphing. So for graphing, we're going to take our two equations and then change our variables to x and y. Doesn't matter which one, just be consistent. So let's say I make my w's x and my f's y. That would be 3x plus 3y equals 1770. And 2x plus 3y equals 1535. If you have problems like this, I would say don't worry about putting in the calculator, just use Desmos. Because then you wouldn't need to change these both to slope intercept form, worry about decimals and things like that. So in Desmos, I would put those two equations. I already forgot what they were. 3x plus 3y equals 1770, is that right? And then, what was the second one?
You get 2w plus 3f equals 1555.
So put those two in, see where they intersect. You can click on that point. You have the point 215, 375. This is also a good way to check yourself if you do it another method. So if you use Desmos, put your order pair down, list them as x, y, and then let's say your original problem had different variables, connect those back to what they were originally. So x was w, yeah. So that would be the work you would need to do. Any other questions on this one? And then going back through the whole thing, were there any questions that we didn't go through just now, but you wanted to see or go over or have questions about? Okay. 14. Okay. This is substitution. So this one's actually easier than the other substitution problems because they already tell you what y is. You just have to substitute this into here. And find that. So this would be negative x plus 2. And then I would solve for x by subtracting 2. And divide both sides by negative 1.
So you're already given the solution.
Yeah, you're already given part of the solution. You just have to find the other part. And you, from this, you know it's going to be one solution, not many or none. So there's less work for you to do. I mean,
Do you want us to write if it's like no solution?
if that's the solution, put yes, NS, no solution, the 0 with the line through it, something that tells me that's the solution. or IMS, the infinity symbol, and let everyone finish writing that one down. Anyone still need 14? Oh. Okay, this one's just like this one. You would set it up 3x plus 15 equals negative 3x minus 9. And then start moving things. So I could add 3x to both sides. Subtract 15 to both sides. And divide both sides by 6. And then put that back in to find 1. Here I have negative 12 and 15. So y equals 3. So my ordered pair would be negative 4 and 3. Any others? No. 23. Does anyone still need 12? I'm going to set this one up and then I'll let you guys continue to solve it. So for this one, important things, we have cost $5 for general admission, $3.50 for students with student ID. We know there were 400 tickets sold. There was a total of 1,580 or 1,080. And then we are looking for both how many general admin tickets were sold and how many student tickets were sold. So we don't have variables. You need to make some or define them. G and S, A and T. You don't need to put the decimals for 5, you can just put 5. For the 3.5, you do need the decimal. And G and S represent what? Say that one more time.
G is like how much school play tickets cost.
Not cost, we're not looking for cost.
The number of how many were sold.
Yeah, so the number of general admin tickets sold. So then S would be the number of student tickets sold. So now we need to set up these equations. We have 4 numbers, that means 3 of them are going to go together. How would we set up these equations, Davina? So all the prices, or money prices, anyway, those would need to go together. Prices and the total would need to go together. What about the other equation?
G plus X equals 1.
G and S fields represent number of tickets, and they have to equal total number of tickets. Okay, so I'm going to leave that there. So you have the equations, you have your variables, and I'll let you decide how you want to solve that. Do you have any other questions? For the remainder of class, when you're working through the problems we did not do, if you finish that and haven't finished the Delta Math and Khan Academy word problems, you can be working on that. If you haven't finished Delta Math and Khan Academy previous system things, you can be working on that. If you have questions, you can bring them up to me. I have some things I need to say. Anyone have questions on what we're doing for the remainder of class? You guys have